Today we're going to learn about the law of sines. Now you've already solved right triangles, that is finding the measurements of sides and angles of right triangles. Today we're going to start talking about solving for sides and angles of oblique triangles. Oblique triangles have no right angles. So let's take a look at an oblique triangle. We'll call this ABC. And you know the sides opposite are similarly named, except in lowercase letters. So across from angle A, we would have side A. Here's side B, and here's side C. We'll draw a height, an altitude, and we'll call it H. Notice with the altitude we've created two right triangles. And what I'm going to do with each of those right triangles is I'm going to write an expression for the sine of A and then for the sine of B. Now we know sine of A is opposite over hypotenuse. So here's A, here's opposite A, here's the hypotenuse. So sine of A is H over B. Now sine B, looking at the other right triangle, here's angle B, opposite over hypotenuse. So sine B is H over A. Now what we're going to do is solve each of these equations for H. So we're going to isolate H. This one will multiply both sides by B. So we'll end up with H equals B sine A. And then the second equation, H is equal to A sine B. Now if H is equal to this, and H is also equal to this, then these two quantities must be equal. So I'm going to write that as B sine A is equal to A sine B. Now we're going to take this equation, we're going to divide both sides by AB. On the left side, the B's will cancel. On the right side, the A's will cancel. And we're left with sine A over A is equal to sine B over B. And this right here is the law of sines. So if we include angle C, this is what the law of sines looks like. This is the law of sines. And you're never going to use all three ratios at once. Okay, you're going to create a proportion, which means using two ratios. So you're going to have sine A over A equal to sine B over B, or sine B over B equal to sine C over C, or sine A over A equal to sine C over C. And if you prefer, you can use the reciprocals, and you can put the side length over the sine of each angle. It doesn't matter which you choose. Okay, so let's say we're given a triangle. We'll call this A, B, and C. Let's say we're told that angle C is 102 degrees. We're told that angle B is 28 degrees. And we're given that side B measures 27 feet. Now, if we are to solve this triangle, that means that we need to find the third missing angle and the two missing sides. So let's start with the missing angle. We've got 28 degrees plus 102 degrees is 130 degrees. And if we subtract that from 180, we get 50 degrees. So angle A is 50 degrees. Now let's work on finding side A. Well, we know that sine of A over A equals either sine B over B or sine C over C. It would make sense to use B because we're given the angle B and the side b. So sine b over b. So if we substitute, we've got sine of 50 over a equals sine of 28 over 27. Now we're just going to solve. We'll cross multiply. We've got a sine 28 equals 27 sine of 50. 27 sine 50 is then divided by the sine of 28. Notice we haven't used a calculator yet, but this is our very last step. And to the nearest whole number, when we use our calculator, we're going to get 44. So side A must be 44 feet. I should add that right there, 44 feet. Now all that's left is to find side C. So here we've got a clean page. We've got our triangle labeled with the measurements that were given and the two measurements that we found. So in order to find side C, we would use sine C over C. And here we have a choice between using B or A. We should get the same answer regardless, but I'm going to go with B because that information was given. We know that that must be correct. So sine 102 over C equals sine 28 over 27. Cross multiply. Divide. Notice no calculator yet. Now we use our calculator. And rounded to the nearest whole number, we're going to get that C is 56 feet. So now we have solved this triangle. We found the two missing sides and the one missing angle. Now I do want to point out one more thing about this problem here. Notice how they gave us two angles and a side, and that their arrangement is angle, angle, side. Just like that theorem that you used in geometry when you were proving triangles congruent. But we'll come back to why that's important. Now sometimes the directions aren't to solve the whole triangle, sometimes they just want a single side or a single angle. Here we're solving just for side A. So we know that we definitely need to use A, but now we've got to choose between B and C. Now if I look at B, I've got angle B, but I don't have side B. I've got side C, but no angle. However, we can find that because we have the other two angles of the triangle. So let's see, 98 plus 43 is 141 degrees. And if we subtract 141 from 180, we get 39 degrees. So this angle up here is 39. So we'll use that in our ratio. We'll use C. So we've got sine of 43 over A, that's what we're looking for, equals sine of 39 over 22. Cross multiply. Make sure you show every step. Notice we're not going for the calculator yet. But if I round to the nearest tenth, we're going to get 23.8 feet. Now also with this triangle, I want to point out that the information they gave us, right, two angles and a side, but it's not angle, angle, side like the previous one, it's angle, side, angle. Okay, that's important, but we'll talk about why another time. So our summary here is really just the formula, the proportions for the law of sines. You can use them either the way that I demonstrated, or you can use the reciprocals. And you want to just kind of keep in mind that we're using law of sines when we're given angle, angle, side, or angle, side, angle. Last, remember that you're going to use your calculator in degree mode, but we're only using it for the very last step.